According to the 2017 National Electrical Code, Section 250.24b governs the grounding of the neutral conductor. This section specifies where the neutral conductor must be connected to the grounding electrode system in a service. The term service entrance is crucial in understanding this requirement. The service entrance is defined as the point where power is supplied to a building or structure. In the scenario presented, a 200 amp residential service drops to a meter, then proceeds to an outside weatherproof fuse disconnect. This outside disconnect serves as the service entrance. Therefore, according to NEC section 250.24b, the neutral conductor must be bonded to the grounding electrode system at this outside weatherproof fuse disconnect. The code mandates that the neutral conductor be bonded at the service entrance for several reasons. Firstly, it provides a low impedance path for ground fault current to return to the source. This low impedance path is essential for the overcurrent protective devices, such as circuit breakers or fuses, to operate quickly and clear the fault. Secondly, bonding the neutral at the service entrance minimizes voltage potential between the neutral and ground. This helps to prevent electrical shock hazards. If the neutral were to be bonded at the panel board instead of the outside disconnect, it could create a situation where a fault current would have to travel through a significant length of conductor before returning to the source. This increased impedance could delay the operation of the overcurrent protective devices, increasing the risk of damage and injury. In a residential service, the grounding electrode system typically consists of one or more of the following: a metal underground water pipe, a ground ring, a concrete encased electrode, a ground rod or ground plates. The grounding electrode conductor connects the neutral conductor at the service entrance to the grounding electrode system. The size of the grounding electrode conductor is determined by NEC Table 250.66 based on the size of the service entrance conductors. The connection of the neutral conductor to the grounding electrode system must be made in a manner that ensures a permanent and reliable electrical connection. This connection should be accessible for inspection and testing. It's important to note that there are some exceptions to the general rule that the neutral conductor must be bonded at the service entrance. However, these exceptions are typically limited to specific situations, such as separately derived systems or installations where the service equipment is located at a distance from the building. In most residential services, the neutral conductor must be bonded at the service entrance. It is important to follow all applicable requirements of the National Electrical Code when installing or modifying electrical systems. Failure to do so can result in electrical shock hazards, fire hazards, and other safety risks. In the specific scenario described, the neutral conductor must be bonded at the outside weatherproof fuse disconnect. Bonding the neutral at the panel board instead of the outside disconnect would violate NEC section 250.24b. The grounding electrode conductor should be sized according to NEC table 250.66 based on the size of the ungrounded service entrance conductors. The connection to the grounding electrode system must be made in accordance with NEC section 250.68. This includes ensuring that the connection is accessible, permanent, and mechanically sound. The intent of these code requirements is to create a safe and reliable electrical system that protects people and property from electrical hazards. By bonding the neutral conductor at the service entrance, a low impedance path for ground fault current is established, minimizing the risk of electrical shock and fire. Here are some additional considerations related to neutral bonding. Firstly, the neutral conductor must be insulated throughout the service. This insulation helps to prevent accidental contact with grounded surfaces. Secondly, the neutral conductor must be identified by a white or grey color. This color coding helps to distinguish the neutral conductor from the ungrounded conductors. Thirdly, the neutral conductor must be continuous from the service entrance to the panel board. There should be no splices or breaks in the neutral conductor between these 2 points. Fourthly, the neutral conductor must be properly sized to carry the maximum neutral current. The size of the neutral conductor is determined by NEC section 220.61. Fifthly, the neutral conductor must be protected from overcurrent. The overcurrent protection for the neutral conductor is typically provided by the main breaker in the panel board. Sixthly, the neutral conductor must be grounded at the service entrance. This grounding connection is essential for providing a low impedance path for ground fault current. Seventhly, the neutral conductor must be bonded to the equipment grounding conductors at the service entrance. This bonding connection helps to ensure that all metallic parts of the electrical system are at the same potential. Eighthly, the neutral conductor must be installed in accordance with all applicable requirements of the National Electrical Code. Failure to do so can result in electrical shock hazards, fire hazards, and other safety risks. Ninthly, it is important to consult with a qualified electrician when installing or modifying electrical systems. A qualified electrician can ensure that the work is done safely and in accordance with all applicable codes and regulations. Tenthly, always energize the electrical system before working on it. This is the best way to prevent electrical shock. 11thly, use appropriate personal protective equipment when working on electrical systems. This equipment can help to protect you from electrical shock and other hazards. 12thly, follow all safety precautions when working on electrical systems. This will help to ensure that you do not injure yourself or others. 13thly, if you are not comfortable working on electrical systems, do not do it. Hire a qualified electrician to do the work for you. 14thly, it is always best to be safe than sorry when it comes to electricity. If you are unsure about something, ask a qualified electrician for help. 15thly, electricity can be dangerous, so treat it with respect. Always follow all safety precautions and use appropriate personal protective equipment when working on electrical systems. 16thly, the information provided here is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician when installing or modifying electrical systems. The purpose of bonding the neutral conductor at the service entrance is to provide a low impedance path for fault current to return to the source. This low impedance path is essential for the operation of overcurrent protective devices, such as circuit breakers and fuses. When a ground fault occurs, current will flow from the ungrounded conductor to ground. This fault current will then travel back to the source through the neutral conductor and the grounding electrode system. If the neutral conductor is not properly bonded at the service entrance, the fault current will have to travel through a longer and more impedance path to return to the source. This increased impedance can delay the operation of the overcurrent protective devices, increasing the risk of damage and injury. In addition to providing a low impedance path for fault current, bonding the neutral conductor at the service entrance also helps to minimize voltage potential between the neutral and ground. This helps to prevent electrical shock hazards. If the neutral is not properly bonded, there can be a significant voltage difference between the neutral and ground. This voltage difference can create a shock hazard if a person comes into contact with both the neutral and ground at the same time. The National Electrical Code requires that the neutral conductor be bonded to the grounding electrode system at the service entrance. This requirement is intended to ensure that a low impedance path for fault current is provided and that the voltage potential between the neutral and ground is minimized. It is important to follow all applicable requirements of the National Electrical Code when installing or modifying electrical systems. Failure to do so can result in electrical shock hazards, fire hazards, and other safety risks. This residential service with an outside weatherproof fuse disconnect necessitates the neutral conductor to be bonded at the disconnect itself, per NEC 250.24b.